find an equation of the plane that passes through the point and contains the line given by this equation, okay, in symmetric form. As we know, to find an equation of the plane, we need two things. Okay, we need a point which is given here, and we need a vector normal to the plane, perpendicular to the plane. Okay, normal, any vector, any normal vector to the plane. So point is given. Now we need to look for normal vector. Once we have these two things down, then the equation, then any equation of the plane is just ax minus x naught plus b, y minus y naught plus c. So normal vector a, b, c. G minus g naught equals 0. Okay, this would be an equation of the plane, and we are done. And we are given that the plane contains this line. Okay, there will be infinitely many lines on the plane, but this is one of the lines. As we know, the symmetric form, this is just line. In this case we have ABC, but this is direction vector. Okay, do not get confused with this ABC and this ABC, they are different. This is direction vector ABC. So here is 1 to 5. So we know the direction vector ABC. That means we know a vector on the plane. Okay, so a vector on the plane is just 1 to 5. So we have one vector 1 to 5. We are looking for a normal vector. Okay, and how do we find the normal vector? That's perpendicular to the plane. If we have two vectors on the plane, let's say u and v, then we can find the cross product, and that cross product will be perpendicular to both. That means that will be the normal vector. Okay, so we need to find two vectors on the plane and find their cross product. So we have one vector v, 1 to 5, just the direction vector. Now we need to find another vector on the plane. Okay, we have a point. If we have another point on the line, then we can find a vector. Looking at this, we can find infinitely many, but one of the points is x naught, y naught, g naught, just one. This is minus 0. So one of the points here is x naught, y naught, g naught is just x minus 1, y minus 0, 0, g minus negative 1, so negative 1. So we have 1, 0, negative 1, one point, and we are given another point. From these 2 points we can get a vector. Okay, let's say u. Okay, so we can find u. U is just this minus this. Okay, let's do over here. Here on the line we have direction vector v, which is 1 to 5, and we are finding another vector u just from the given point and from the point here. Okay, let's say this is P and this is Q. So PQ, or it could be QP as well, it does not matter. PQ 1 minus 1, 0, 0 minus negative 2, just 2, negative 1 minus 3, negative 4. So we found two vectors on the plane. Now we find their cross product, u cross v or v cross u. Okay, that will be normal to the plane. Okay, let me find this cross product here. So the cross product is negative 18, 4, 2. So this is one of many normal vectors to the plane. In fact, any constant multiple of this vector is also normal. So we can divide by 2 and make it simpler, okay, if we like. Now for our context here, equation of plane, so we need normal vector ABC. So this is ABC in our context. So this is ABC, and point is 1, -2, 3 is given here, and that's x naught, y naught, z naught for us. In fact, we can use this point as well, because this is also a point on the plane. Okay, thus an equation of the plane is just using this formula, just plug in the values and we are done. A is -18 x minus x naught, so I forgot that, 1, -2, 3. Okay, 1, -2, 3, or we could have used 1, 0, -1. X minus 1 plus b is 4, y minus, that's -2, so plus 2 plus c x minus, sorry, g minus 3, because the x naught is 3, equals 0. This is in the standard form. You can simplify and move the constant over. That would give us general form of the plane, but this is good enough. Final